Starting with Google's breakthrough discovery, a big research team in partnership with Google Quantum Computing Lab state that they have made the world's first ever time crystal. To understand what time crystals are, we need to keep in mind two core concepts, which are Newton's first law of motion and thermal equilibrium. Under these laws, there cannot be perpetual motion, as at one point an object will come to rest due to external forces such as inertia. However, time crystals completely defy this, as time crystals are a quantum system of particles whose lowest energy state is one in which the particles are in a repetitive motion. The system cannot lose energy to the environment and come to rest, because it is already in its quantum ground state, thus enabling motion without energy and making time crystals a special phase of matter. In addition, the second law of thermodynamics states that the universe is always moving towards entropy, and if there are no processes, it will remain the same, while under processes, it will always increase. Time crystals also defy this law, as their entropy remains stable over time, instead of increasing as they change states back and forth without the use of energy and perpetually. So why does this discovery matter? Well, it can be a huge breakthrough in the technology world and can not only make quantum computers a reality, but can also lead to new ways of powering the planet. The research is currently in the pre-publishing phase and is waiting for peer review. If Google's time crystals are proven to be true, it would change the world virtually overnight. That is not the only discovery Google has made in the realm of quantum computing. Google has also demonstrated a step towards error-corrected quantum computers. In classical computing, everything is in the state of either 0 or 1 and thus allows for quick error identification and correction. However, quantum computers defy this as they operate through qubits. Qubits are exotic states neither representing a 1 nor a 0 and are highly susceptible to noise such as electromagnetic waves, which makes them extremely hard to measure, as an attempt to do so can destroy the data. However, researchers at Google have managed to measure the error through a process called entanglement, which clusters multiple qubits to measure them. This was demonstrated on Google's Sycamore quantum computer, with the physical qubits ranging from 5 to 21. However, Google's error correction does not meet the threshold, where the error identification features catch more errors than the increase in qubits. More so, for this to become practical, such procedures need to be tested and evaluated on large scale, such as using 1000 physical qubits, whereas the Sycamore has only 52. Nonetheless, it is a way forward towards the practicality of quantum computers. And speaking of the way forward, Google has released a few details regarding its Pixel 6 and Pixel 6 Pro. Google states that the new Pixel will incorporate its indigenous system on chip called Tensor, which will greatly improve the AI and machine learning in the new models for smooth functioning. Moreover, the new models will be based on Android 12 and will feature an upgraded rear camera system, thus the addition of camera part to fit the large camera. The new phones will also have new materials and finishes, such as the Pro's light polished aluminium frame and 6 matte aluminium finish. Google states that the phones will debut this fall, and that is when more details regarding it would be released. One thing is for sure, it's going to be premium priced. Tensor is not the only Google processor in the news. The company's new set of algorithms by Google Brain can now design AI software tailored chips and can outperform experts in that. This is done through a type of machine learning termed deep reinforcement learning, which is based on the workings of the human brain, and its small application can be seen in games such as chess. Chip designing is a complex task as it requires millions of components to be optimized and work in harmony, and that too on size no longer than a fingernail. The research team behind this project trained the AI with 10,000 chip floor plans so that it could explore alternatives to design optimal chips. The AI works by trial and error, where feedback is used to improve the overall neural network, and the system can adapt and generalize. And their AI agent needed just 6 extra hours of computation to identify optimized solutions for any specific needs. Moreover, this AI network can slash the time taken to design chips from months to just hours, and the researchers state that they plan to release the code for the broader community. Speaking of neural networks, Google in partnership with Harvard has published an intricate map of every cell and connection in a cubic millimeter of the human brain. This dataset includes tens of thousands of reconstructed neurons, millions of neuron fragments, 130 million annotated synapses, 1 of 4 proofread cells, and many additional subcellular annotations and structures. This is by far the largest sample of brain tissue imaged and reconstructed in this level of detail in any species, and the first large-scale study of synaptic connectivity in the human cortex that spans multiple cell types across all layers of the cortex. This map will provide novel and information-rich ways to study the human brain. You can also view it for yourself through Neuroglancer. All is not smooth sailing for Google, however. In June, the company was fined €200 million by French competition authorities for abusing online advertising dominance, as the authorities found that the Google Ad Manager favored Google AdX, its own online ad auction platform. Google had to make changes to its platform. Furthermore, just last month, the company was fined €500 million by France Competition Authority over copyright issue, as news outlets demanded to share more revenues. The ruling stated that Google must come up with suitable proposals to recompense the outlets within the next 2 months, and failing to do so could mean additional fines of €900,000 per day. Google told the BBC that the company was very disappointed with the decision, but they will surely comply, and the company has also agreed to pay $76 million to over 120 French news outlets. That's it for this week. Please don't forget to give us your valuable feedback regarding Google's discoveries and this report.